What's up, everybody? This is Mr. Trummer, and I'm going to walk you through how to solve these four problems that we set up for you earlier. So the first one here being x plus 7 equals 13. Whenever we're solving for x, we need to get x by itself. And to do that, you always need to do the opposite of whatever is still with it. So right now, you see that we've got a positive 7 here. Well, to get rid of that 7, we have to take it away. And because we're taking it away on the left side of the equation, we also have to take it away on the right side of the equation. So that cancels out these these 7s here, and we are left with x is equal to whatever 13 minus 7 is, which mental math tells me 13 minus 7 is equal to 6. So you should have gotten x equals 6 for your first problem here. Now, let's do number 2. Coming over here to number 2, we have x minus 8. So once again, we need to do the opposite of what is being done on the same side as the x. Since we have a negative 8, this time we need to add our 8. And we can't just do it on the left side. We also have to do it on the right side as well. So once again, these 8s cancel each other out, and we have 4 plus 8 over here, which tells me that x is equal to 12. 4 plus 8. That's a lot cleaner when I do the box, so we'll stick with that. All right, so that's 2 problems down, and don't worry, I will zoom out to where we have everything on the screen at once. All right, now let's look at this one. This one's a little more tricky because we have 2 things over here with the x. We've got this 3 that's directly attached to it, and we have this negative 2 that's over here. Now, the way we solve these is we simply have to get rid of what I call the furthest away from the x first, okay? So what I mean by that is this 3 is like right up on top of the x, right? He's going to be kind of hard to get rid of. He's kind of stuck to him like glue. But this negative 2 over here, it's kind of hanging off to the side. It's a lot easier to kind of push him aside. So when we have a negative 2, we have to, just like we did before, do the opposite. So a negative 2 means we have to add 2 to that side to get rid of it. If we're going to add 2 on the left, we've got to add 2 on the right as well. So that cancels out these. We're left with 3x on the left. And then what is 25 plus 2? Well, that is 27. So we've got 3x still remaining on the left side equals, and we said that this is equal to 27. So, woo, that's a weird looking 7. 27. There we go. A little better. Not much better. That's okay. Now, we still have an equation here that we got to take care of. Okay? I still have this 3 over here with my x. I don't want anything with the x. So if you remember back to 8th grade, when you have 3x, what we're really saying is 3 times x. Well, if we've got 3 times x, we've got to do the opposite to get rid of it. The opposite of multiplication is, of course, division. So I'm going to divide by 3 on the left, divide by 3 on the right. That cancels out these 3's. I'm left with just an x. Uh-oh, where'd everything go? Let me get back down there. Hang with me. It's a slow trek back down to problem 3. All right, I'm left with x. And I have 27 divided by 3 on the opposite side. If you remember, 27 divided by 3 is what is actually my favorite number, 9. So we are left with x is equal to 9. All right, 3 down, 1 to go. Certainly can't get much harder than that, but let's see what we got. Oh, boy. All right. Well, the first thing I notice is that I put a comma after the 4 over there. That's disappointing. That's okay. We're too far into this to change it up now. So we have x's on both sides of the equation. We've already talked about how we need to have the x by itself. So here's what I'm going to do. I've got 3x on the right and I've got 1x on the left. I want to bring this x right here. I want to bring that over and combine it with this x. And how I do that is like this. If I have a positive x over here on the left side of the equation, I'm going to take it away. So if I have a positive x, goodness, I'm struggling here. If I have a positive x, to take it away, I just subtract an x. Simple as that. But if I do it on the left, I have to do it on the right as well. That cancels these x's out. Now I go from 3x, and because I took one x away, I now have 2x over here. Okay? But we can't forget about that 5 and the 9. So I've got 2x minus 9 on the right side of the equation, and I still have that 5 on the left side of the equation. All right. 5 equals 2x minus 9. Well, the goal is, oh my goodness, I did it again. The goal is to get x by itself, right? So to get x by itself, I've got to get that 2 and that 9 out of there. Well, remember from problem 3, it's a lot easier to get rid of the thing that's further away first. So let's go with this handy dandy blue. And I've got a negative 9. Well, to get rid of it, my goodness, to get rid of it, I have to make sure that I am doing the opposite. Well, doing the opposite of negative 9 is adding 9. So I'm going to add 9 to both sides of my equation. Okay? 5 plus 9, that is equal to 14. And just like before, these cancel out. Let's try that again in red. Those cancel out. All right, so I've got 2x is equal, or actually I have 14 equals 2x. And before we talked about how when you have yourself 2x, you're really saying it's 2 times x. So to get rid of it, we've got to divide. I divide both sides by 2. That will cancel out that 2, and I'm left with, let's do this in light blue now. Let's finish. Actually, we've done everything in green at the end, so let's keep it like that. 14 divided by 2 is equal to 7. And all we have left on the other side is x. Now it's okay that I have 7 equals x. I personally like to say x equals 7. So at this point, I just flip it around. It's no big deal. You're not doing any kind of world-changing math here. So x equals 7. Box it in. Bang, bang, boom. You've got 4 solutions to your 4 problems, and I'll zoom out so that you can see all of that work all at once. This is the answer key. Hopefully this helps you in solving these problems and helps you for problems down the line.